Hey guys, hope you guys are having a great day. We're going to have a what I would consider a pretty playful day here, looking at graphs of trig functions, because what we're going to start to do today is we're going to start first off by combining multiple trig functions together into one function. We're going to see what the graph looks like. So like I said, it's going to be pretty playful. We're going to take a look at the graph. We're going to notice things. We're going to wonder things. We're going to try to make some connections. We'll also look at combining a trig function with a function that's not trigonometric and see what happens with those graphs. And then eventually, probably not in this video, maybe in the next or the third video, we'll actually look at some applications of what happens here. So we'll first look at what we call addition of ordinates. And probably not a term that you guys are really familiar with, but ordinate is actually the name for the y-coordinate, right? So you have your point, you have your x comma y, we call those the coordinates of the point, while the y-coordinate is actually called the ordinate. So you'll see this sometimes, and I just wanted to talk to you what that means. If you're wondering what the x-coordinate is called, it's called the abscissa. Really interesting name. So you got the abscissa for the x-coordinate, the y-coordinate is the ordinate. So addition of ordinates, we're going to be adding two functions together here. Our function is 2 times the sine of x plus the sine of 2x. We're going to add those together. And the reason I'm calling it addition of ordinates is because when we add two functions together, what does that mean graphically? It means that we're adding the y-coordinates together. So let's do this. Let's first graph this function, 2 times the sine of x. We should already have a picture of what that looks like in our mind. Let's graph the sine of 2x. Again, we should have a picture of what that looks in our mind. But then let's think about what happens when we add those two functions together. So let's go to decimals. And let's put in our first function, 2 times the sine of x. There it is. No shocker on that one. Let's do projector mode. Let's change this to count by pi's maybe. Yeah. There we go. All right. So our amplitude on this one is 2. Okay. Our period is still 2 pi. Nothing has changed there. So that's what this function looks like. I don't really like that these are rectangular. Let's see if I can square that up a little bit. Looks a little bit better. Okay, now let's put in our other function, which was the sine of 2x. Now we know if we put that 2 there we go, we know that is going to condense horizontally and shorten up that period. So the sine of 2x we know still is an amplitude of 1, and its period is just pi now instead of 2 pi. So that's what the graph of those two functions look like. Now what's it going to happen when we add these two functions together? Let's just plot a couple points and let's see if we can determine what we think is going to happen. All right, so let's see here. What color should we make our new one? Let's do green. Let's pick some easy points to graph. How about at 0? Well, the y value of our first function is 0. The y value of our second function is 0. So when we add that to get 0 plus 0 is 0. Okay. Do you see another easy point for us to graph? Okay. Well, I look at pi over 2. Now the blue curve has a y value of 0. The red curve has a y value of 2. Well, what's 2 plus 0? That's 2. And I see adding those together would be 0. Adding these together would be negative 2. So just looking at those right now, it seems like it's matching that red curve a little bit. But there's probably a lot more that's going on with this function. Let's pick a different value, such as this one here at pi over 4. Now, I need to take this y value, which is 1, and I needed to add it to this y value, which is what, maybe 1.4, something like that. I always love this visual, is if I take that y value and I add it to the other y value, I can just, let me grab that. There we go. I can just stack it on top. So that's the blue y value. Doesn't look like I have red here ready to go, so we'll use pink. So this y that's the y value of the red curve, and I've added on the y value of the blue curve, and our new point is way up here. So you may have been inclined to think that this is the maximum, but it's not. We see this point is actually higher. And we can do this with lots of points. Let's look at this. Let's look at 3 pi over, no, that was pi over 4. 3 pi over 4. Okay. Well, the y-coordinate of our blue curve is negative. The y-coordinate of our red curve is positive. When I add those together, I'm not going to stack it because it's negative. We actually have to bring it here and bring it back down, and our new point is right there. Okay, what's going on with this curve? This is really interesting. Let's go back to Desmos. Let's add them together. All right, 2 sine of x plus the sine of 2x. And look at that cool looking graph. Okay, that's kind of matching up with what we saw. I didn't have it drawn in here, but it kind of comes up here. Yeah, I think I missed that just a little bit. This is a little bit of a struggle. It's got to come back to there. There's another point, right? Something kind of like that. Oops. There we go. Okay, so let's turn these other two graphs off. We get this really cool looking curve when we add those together. Now, what do you notice about this? Okay. Well, one thing that I notice is it's still a periodic function. Periodic meaning it repeats. It has a period. And the question is, what is the period of this function? How often does it repeat? Well, it starts at 0, heads up to this number, okay, heads back down to 0, goes back down to this number, and we're back to 0 again there, and then it repeats. Let's get rid of that point. Okay, it repeats every 0 to 2 pi. Now let's think about why that makes sense. If we look at that function, 2 times the sine of x, what's the period of that? Well, that repeats every 2 pi. Now this function, okay, we already mentioned this already, that 2 in there is going to horizontally compress it down, and the period's going to go from 2 pi down to pi. That has a period of pi. So what happens when we add those together? Well, this repeats every 2 pi. This repeats every pi. Does it make sense that the period for this function is still 2 pi? Why does that make sense? Well, it repeats, this part repeats every pi, but this hasn't repeated itself yet. This doesn't repeat itself to 2 pi, which is a multiple of pi. Now, we're going to look at what happens when one period is not a multiple of the other. Let's see if we can figure that out. Okay, so we get that cool graph. I think we should probably take a picture of it. It's so cool. There it is. All right, let's go to another one. 2 cosine of x minus the sine of x over 3. Now, we are subtracting, which is going to work like addition. Okay. But let's see if we can guess what the period is here before we graph this one. What's the period of this function? 2 pi. What's the period of this function? Okay, we've got an x over 3, which is really 1/3 x. So we know that 1/3 is going to horizontally stretch it out by a factor of 3. Okay. If you really like the formula 2 pi over b, we would just say this is 2 pi over 1/3. Dividing by 1/3 is the same as multiplying by 3. which is 6 pi. So how often is this function f of x going to repeat when this part has a period of 2 pi and this part has a period of 6 pi? Well, again, the period can't be less than 6 pi because it takes 6 pi for this one to repeat. Now this one does repeat every 2 pi, which happens to go nicely into 6 pi, where we see this is a multiple again. Okay? The period of this function is going to be 6 pi. Let's graph it and let's see what happens. All right, so let's turn that off. What was our first function again? 2 cosine of x. Okay, looks like that. Looks pretty good. Our second function was a sine of x over 3. Let's see here, we'll do it like that. Okay, that's going to be a stretched out version of the sine function. Now, what's it going to look like when we subtract? Well, let's pick a few points here. 0 and 1, and we're taking the red minus the blue. 1 minus 0 is 1. So we have that. Now, what happens right here? These two curves are intersecting at that point, which means their y values are the same. So when we subtract them, what's going to happen? We're going to get 0. How about this one? Now we're taking red minus blue. 1 minus, negative 1 minus 1/2 is it's actually going to put it down here. It's not perfectly 1/2, but close. All right, how about this one? 0 minus 1, negative 1. Here they're the same again, but now how are we subtracting here? We're taking red minus blue, so again that's 0. Red minus blue, be probably right about there. Here they're the same again, so that's 0. Red minus blue, going to put it right there. Okay, so it looks like something's kind of coming down like this, coming back up, coming down. I'm only to 3 pi. Now we said we expected this period to be 6 pi, so we could continue to do that all the way out to 6 pi. So let's jump to Desmos here. 2 cosine of x minus the sine of x over 3. Put them together, and that's what we have. Is that kind of matching up with what we had? It started at the top, went down underneath both graphs, came up short of the red one. Yeah, that looks pretty good. Let's turn off these others. All right, is the period 6 pi? Okay, kind of hard to look at here. Let's see. It starts there. Is it back to where it started at 6 pi? Yes. Dipped down low, came back up kind of moderately, went down moderately, went up high, back down moderately, came back to where it started. Does that repeat? Yes, it does. All right. Let's see what's next. Okay, we've got about a minute left on this video. What I think I'll do is I'll just put this example in the next one. So our next video will be this addition one, and then we'll get to multiplying.